Hello, algebra students. This is a lecture on multiplying and dividing rational expressions. This is section 8.4 in our text. First question is, are you smarter than a fifth grader? Do you know how to do 2/3 times 3/4 without your calculator? Hopefully you guys do. When you are multiplying a fraction by another fraction, all you do is multiply the numerators across and you would get 6, and multiply the denominators across and you would get 12. You'd look to reduce your fraction if you could, and you would end up with 1/2. So hopefully you guys remember that that is how you multiply a fraction times a fraction. Let's move on to some 6th grade standards. Let's see if we know how to divide fractions. This one stumps a lot more students. Back in the day when you learned this, obviously without a calculator, your teacher might have taught you something like keep, change, flip, or something along those lines. Essentially what you do when you divide a fraction is the first part will stay the same, but you change the division into a multiplication and flip the second fraction. So that's where keep, change, flip would come in, or some other little quirky catchphrase. Now it's just a multiplication question, and we can multiply the numerators across and get 16, and multiply the denominators across and get 15, and I'd be very happy with that answer. Remember, we are studying rational expressions right now, and rational expressions are fractions where you have a polynomial on the top and you have a polynomial on the bottom. And in today's lesson, section 8.4, we are going to actually multiply and divide some rational expressions. Notice we're going to have fractions here, and we're going to be multiplying this by another rational expression. So some more fractions. You can probably see where this is going to come to play. There's actually 3 different tasks we're going to do. We're going to start with just simplifying rational expressions, where you just have a polynomial divided by a polynomial, and you guys try to simplify it. We're also going to multiply them and then divide them. Your steps, pretty much regardless, would be to factor at the beginning as much as you possibly can. Factoring means that you guys are going to need to know just general factoring, as well as factoring out the greatest common factor, as well as factoring when the a value is greater than 1, so the box method. Then, after you have factored it completely, you would look to multiply or divide, and then look to do any simplification. Just kind of, old news. We know that AC over BC. We could cancel this to the C's would cancel, and you would have A over B. Let's look at a little bit more complicated version of this. If this was our expression, this would be very much a rational expression of a polynomial divided by another polynomial. This is our A here, this would be our C, and then B, and then C. We can still cancel out our x plus 3 and our x plus 3, and we would just be left with 4 over x minus 5. Now notice we had parentheses around this denominator here. You can absolutely put those parentheses there. They're not needed. If you have something like x minus 5 in your denominator, it's assumed that it's in parentheses. So you don't need them. I generally won't write them, but I wouldn't mark it wrong if you had them. So this would be a good example of a simplifying a rational expression type of question. We're not multiplying or dividing them yet. We just have a rational expression, and I want you guys to try to simplify this. What you would want to do is you would want to factor this as much as you could, and both the numerator and denominator are factorable. 2x squared plus 10x, we could factor out a 2 and an x. And when we factor out a 2x, we'd be left with x plus 5. Now, our denominator here is a little bit more difficult to factor this. There is nothing that they all have in common. I would first look for that. They don't have anything in common. So then I would have to factor it. And because this has a leading coefficient of 3, I'm going to need to use the box method. Hopefully you guys are all good at the box method at this point. First term in the first box, last term in the last box. Multiply the coefficients 3 and 5. And then list the factors of that number, looking for which factors get you to our middle term, which is 16. If both the 1 and the 15 are positive, then they would add the 16. So 1x and 15x go in these 2 boxes. Now find the greatest common factor of the top 2, and that would be just x. And x times this guy needs to be 3x squared, 5, and 1. So our denominator here factors into 3x plus 1 and x plus 5. You're going to look to simplify anything if you could, and they both have an x plus 5 in the numerator and in the denominator. And so our answer here is 2x over 3x plus 1. It's really really common for students to look at this question and be like, right away. So let's go back to the beginning and be like, this one has an x squared and this one has an x squared. This one has an x. This one, something like that, or like 10 and 2 simplify. None of that can happen. Remember what I said earlier. If you just have a fraction like this, it's assumed that this is in parentheses and this is in parentheses. You're not going to be able to just go in and start canceling stuff inside the parentheses. The entire parentheses would have to match, like these ones do here, and then you can cancel it. Let's do one more. Pause it here. You guys try it. Just factor the numerator, factor the denominator, look to see if anything can cancel. Give you a second, pause it, try it, push play. This numerator factors into x minus 5 and x plus 3. It's because negative 5 and positive 3 do multiply to negative 15 and add to negative 2. The denominator are both perfect squares being subtracted, so that will factor into x plus 3, x minus 3. You have an x plus 3 in the numerator and in the denominator, and what you'd be left with would be x minus 5 in the numerator and x minus 3 in the denominator. I want to reiterate what I said in the last slide. You cannot go in and cancel this x and this x, for example, and just get negative 5/3. That's not true. Remember, this is in implied parentheses, and so is this. And you wouldn't think to go inside the parentheses and cancel them. And actually, I can show you a really easy example that kind of proves that what you're doing isn't accurate. If you have x plus 1 over x, for example, and you were like, hey, they both have an x, I'm going to cancel it, you would always get 1. You would say these expressions are equal. They're not, but you would say that. And of course, we know that this isn't 1, because if I plug in any random number for x, if I plug in 3 and 3, or 2 and 2, or 5 and 5, they're not always canceling to 1. And so remember, this is implied parentheses. You can't go in and start canceling stuff like that. That would not be okay. Boom, answer. Let's look at an example where we're then multiplying them. Now we have a rational expression being multiplied by another rational expression. Step 1 is just going to be to factor everything you can. I can factor a 3x out of the numerator here, the first numerator, and out of the first denominator, I can factor this as x plus 5 and x minus 1. And this is being multiplied by my numerator up here is factorable, x plus 5 and x minus 4. These numbers multiply to negative 20 and add to 1, and there's a 3x here. Now, when you're multiplying, remember, you're just multiplying the numerators across and the denominators across. And when you multiply stuff, you just write it next to each other. So essentially, I'm just turning this into one big fraction, 3x, x minus 1, x plus 5, x minus 4. And that is being divided by x plus 5, x minus 1, and 3x. We generally like to write that 3x out front. I'm just going to do that. Now you're going to look to cancel stuff, and a bunch of stuff should cancel here. The 3 and the 3 cancel, the x and the x cancel. An x plus 5 and an x plus 5 cancels, and actually an x minus 1 and an x minus 1 cancels as well. You're just left with x minus 4 as our answer. I love chapter 8. I think it's really fun. I think the graphs from the previous 2 sections were fun, and I love this canceling process where we just get something relatively simple from something that was relatively complicated at the beginning. Similar level question, pause it here, try it for yourself. X plus 3 over x plus 5, x minus 5, times, I can factor a 2x out of there and get x minus 5, and I can, this doesn't have anything to factor, I just get 2x squared. Remember, there's implied parentheses around this. I can just multiply the numerators across and write it actually in any order I want. I'm going to put the 2x out front. Same thing over here. If the denominator, we have a 2x squared, and then I'll write the parentheses. Looking to cancel, the 2's cancel. This x cancels one of the x's here, so it's not x squared anymore, it's just x. And the x minus 5's cancel. X plus 3 over x x plus 5. Love this answer. I want my answer to be completely factored at the end, just like this is. We just have two problems left. They're both going to be division problems. This really isn't more difficult. It's just one extra thing to think about. We have a 7x, and we can factor a 2 out of there to get x minus 5. And then remember, when you're dividing fractions like this, keep the first one, change the sign to multiplication, and then flip this. For the sake of space and time, when I'm actually doing this, I don't flip it. I flip it at the same time that I factor this. So I can take this statement, factor it into x minus 6 and x minus 5, but I'm not going to write it in the denominator like it was. It's now going to be in the numerator. And what was the numerator is now going to be in the denominator, and it factors into x minus 6. Now it's multiplication. I'm going to multiply the numerators across, and I get 7x, x minus 6, x plus 5. And over here, I'd have 2x. So 2 and x, I'll write those things first. X minus 5 and x minus 6. X minus 6 is cancel. Looks like I have copied something down wrong. That it was x minus 5 up here, and then it changed to x plus 5 somehow when I rewrote it. So x minus 5 right there. X minus 5 is cancel, and the x's cancel as well. And I just left with 7 halves, which 3 1/2 or 7 halves. Who would have thought that this expression would cancel down to 7 halves or 3.5? One more to try. Go ahead and pause it here. Try it on your own. See how you do. Once again, you're going to factor everything as much as you can. I can factor a 5 out of this one to get x minus 4. Change it to multiplication, and then flip these. The denominator is going to factor into x minus 4 into x minus 2. And it gets written in the numerator now. Within the old numerator is going to get written in the denominator, and I can factor out an x. Smush it together. Numerators across, denominators across. 4x, x minus 4, x minus 2 over 5x, x minus 4, x minus 2. Cancel, 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 cancel. 4/5. Heart. So much fun. Please let me know if you guys have any questions. This has been section 8.4 on multiplying and dividing rational expressions.